Likewise, likewise. Thanks so much for having me, everyone. Well, first, I am sad that I'm not over there. I've been to Melbourne once and with a good friend, and I believe that is where I had the best chai latte of my life repeatedly. Well, I'm Sharon. I don't know how much was said in the intro. I'll give a quick background on myself super quickly. So, Sharon, I'm co-founder CEO of Lamini. I left Stanford to start this company. I was faculty there in computer science, leading a research group in Gen AI, where I also did my PhD in Gen AI under Dr. Andrew Ng. I teach about 500,000 students and professionals online in Gen AI. It's really a deep passion of mine to make this technology more accessible, both from an educational standpoint, but also from just a technology accessibility standpoint. I feel like there are only a few hundred of us who can truly deeply control these models. And I would like there to be far more folks who can actually do that because I think you can embed so much expertise and knowledge into them. And yeah, so I'm just really excited to speak with you here. And I hope, like my hope is that like you get at least one thing out of this. So please feel free to ask questions. I want to make sure I allocate time for questions so that every single person here can get at least one thing out of it. I know there is a range of folks here. So yeah, happy to dial it up or down on, whether it be on the business side of things or in terms of getting business outcomes from LLMs, or it's from the technical side, happy to dive deep in that as well. So yeah, thank you so much for spending this time together. So I'm going to present a few slides, maybe just to like get some thoughts going and share a bit with you. Kind of what I was told was, to hear a little bit more about what's going on in the heart of Silicon Valley and in terms of the AI, Gen AI world. And yeah, so happy to share kind of learnings we've had and also things that I've been building out from the technical side. And feel free to ask questions throughout. I'll pause throughout, but no pressure if you want to just sit around and listen. So this is me and my co-founder Greg. I think he's worth noting. He has I believe, far more impressive technical background than myself. He was one of the original architects on CUDA at NVIDIA, which is building out, really NVIDIA's moat on their GPU. He invented AI scaling laws and tensor cores, which is one of NVIDIA's big moats. And then he put the first language models and artificial neural networks onto GPU in production versus just CPU. They were running on Jeff Dean's MapReduce cluster in Google Brain before that. And he did that all at Baidu with my PhD advisor, Andrew Ng, who is the person that introduced us originally back in the day. He's deployed LLMs to now over 1 billion users to the Baidu search engine. And he went on to then co-found MLPerf, which is the industry standard for machine learning performance for both inference and training benchmarks. So when you see like benchmarks out there from Google, NVIDIA, et cetera, that was started by him for us to even understand how well do these GPUs, but how well do these models even run. So, something that I think about a lot is, what are the high ROI and the highest ROI business outcomes we can get out of LLMs today? And I've talked to a few hundred business leaders now who are, deploying different Gen AI applications out there. And I'd like to share a few of those with you out of the different clusters I'm starting to see in terms of the different use cases that are driving real business outcomes and are connected to success metrics. So one that I see is around product specialists. So, a success metric is, or sorry, let me just step back. A product specialist, you can imagine Apple Care or, the Genius Bar at Apple. Also had a conversation with Louis Vuitton. So they have all these product specialists helping you, me out with the things they've created. And they do have, specific, technical understanding of these products, or maybe even there are a bunch of different SKUs. I think Louis Vuitton has several new SKUs coming out every single day, actually. So to be knowledgeable in that is is difficult, especially when there is actually high specialist turnover relative to the rest of the company. So being able to support specialists in that task is very valuable and connects back to a metric of their productivity, but also being able to jumpstart a new specialist. And so this kind of permeates many different industries, but is pretty key to operations and operational efficiency, and also driving what's possible in terms of getting large language models to be able to not just understand generally what is Apple, what is Louis Vuitton, for example, but to understand the actual new SKUs that are coming out for a particular product, and understand all the different aspects about them, and specifically not to hallucinate around them, right? So to be able to have up-to-date information and to have accurate information so that you can best serve customers. So that's one I'm definitely seeing. Another one I'm seeing is around a field technician. So this is similar in some way, but essentially even more, arguably more in a STEM-oriented kind of field, and maybe around fixing, let's say, elevators is one of them. So, these technicians kind of go out into the field and are asked to do a variety of different tasks on hand, and there are new methods to improving, to fixing some of these things, and a lot of the knowledge is inside of the heads of these technicians. And one of the challenges is that these there are fewer and fewer people who can kind of service, in this case, these elevators. So how do we actually augment that when there are so many customers who do need that help? It's funny, I actually today was talking to someone about this, and they said, "Wow, my TKE elevator is broken right now. I'm very upset about this." So it's kind of funny that that it's a common thing, to kind of need help with fixing these things, and there's not enough help to go around. Cool. And it's a very highly technical type of area. So something like just very general just doesn't seem to to work. Next one is again around the product recommendations. And you can imagine like an LLM understanding interesting domains around like engineering, but interesting domains around, in this case, I'm thinking about like nutrition, maybe fitness. And how do you get the LM to also be aware of what products you have available to surface those to the user while understanding something more general? And specifically, I'm thinking about, like, for example, Instacart. Like, they have a ton of, right, groceries in their catalog, billions, in fact. And when they use general LLM, to help recommend things, it can say salsa to go with chips, but it won't tell you what brand of salsa, right? It won't tell you Tostitos salsa because that's close to you at sorry, I'm trying to think of an Australian grocery store, but I'm failing to. Do you guys have Trader Joe's too, or Costco or something? No, okay, sorry. But essentially, so to be able to find the right recommendations near you with, very, specific products associated with that, while still understanding common sense things around like chips do go with salsa. And, maybe when there's a Taylor Swift concert in town, like I will recommend things that are pink or sparkly. And so I think being able to actually capture that information and provide that to the user has been helpful from them as well as a new product category. And finally, one that I see often is around custom code. So, GitHub Copilot has been an incredible product for many users out there, including myself, including those at my company. And it's great for, day-to-day generic things that we're building out. But for many folks that I talk to, there's a lot of custom code. And in fact, there's some sensitive code that we have as well that we don't feel comfortable necessarily sharing. And it's deep. It gets, it could be millions of lines of code. And so how do you get to actually understand all of that and be able to plug into custom custom systems and custom functions. So just really being able to read through those millions of lines of code and actually be able to debug in an automated way to assist usually very, very technical teams. We've talked to a team that they're like, there are not enough PhDs in the world to be able to, for us to hire and to be able to innovate faster and beat our competitors. So they're like, there's no other way. This is the only way we can stay ahead. Cool. So those are some of those different areas. Kind of curious if anyone has any thoughts or has seen other things. I think I definitely see also, of course, the usual kind of what I think of as a little bit more shallow use cases, but can definitely, help kind of organize information internally and be able to understand surface level things where the risk of hallucinating on them is much lower. It doesn't impact the the use of that LLM where, there's not deep technical knowledge or deep knowledge that is different from what is necessarily out there on the internet. And so I think like this is about, designing new products, creating new products that really do affect the top line of a business. But I do see a lot of blockers as well. And I'll just share kind of the blockers that I've been seeing as patterns. One is that it's really hard to get these models to go beyond, and this is really like go beyond like a pilot to production. It's like, oh great, we can get a demo up and it kind of gets at all of these use cases, but the model fabricates information. It makes things up because it's seen other things in its past. Even if you're able to tell it like this is the truth, we had one where they're looking at insurance contracts, legal contracts, and the model had seen that legal contract and it's essentially on the internet and just decided to hallucinate what clause 8 was, even though internally clause 8 was updated to be a different clause. So it just couldn't, even though it could see the updated document, it just still kind of retrieved in its weights, its mind, arguably to hallucinate the past information. So this is a big blocker. Another blocker is it's like, okay, so I heard that, tuning these models will be great to get me better quality, but this seems kind of expensive. And I really do need it to match the ROI of my use case if it's really that expensive. And so basically vanilla ways of tuning the model, it is expensive. It's expensive in both the cost of the compute that you're running it on, like GPUs. It's also expensive in like time, effort, engineers kind of working on it. The next thing is around security. I see this kind of blocking deployments as well, especially when it is a high ROI use case on, for example, in Instacart's case, that is their most important data set. That's the core IP. They're like, this is our core IP. This is like an extremely deep derivative of my data, my most important proprietary data. So just having, being able to overcome just pretty deep security risks that have already been in place, like security compliance, already in place for where data should be today. That's important. And finally, just reliability of the infrastructure. A lot of the tooling out there, very exciting, just like constant stream of new things popping up with new blog posts on everything, kind of promising the world and more, but that don't necessarily scale, that don't necessarily go beyond one demo use case. So seeing a lot of cobbled together infrastructure that cannot actually serve more than, let's say, like one engineer working on it reliably. So it turns out that with just shallow control, if we find that it's just not enough to be able to build out high ROI use cases. So essentially the opposite of that is deeper control of these models, and that's needed to ship these higher ROI use cases in production. Sorry, it turns out reliability really wants to be on the slide, so here we are. But first is just what model quality, right? Removing those hallucinations, having a path to removing them. I think people are starting to hit a wall with the techniques that are easy. Predictable costs of being able to understand, well, okay, if this is going to be expensive, what ways is it? Can we reduce cost dramatically? There are many ways to reduce that cost, also to get started in a way that is small. Security, so being able to actually deploy wherever your secure environment needs to be, or your customer's secure environment needs to be, whether that be on-premise or in VPCs or across, different types of computer environments. And finally, just reliability. So instead of, I think engineering time is arguably where a lot of the costs are going, just like team time, people's time. And so making sure that they're not spending all that time debugging things they don't necessarily need to debug, that's extremely important as well. And we kind of call this type of tuning and deeper control of general LLMs as a way to get to expert LLMs. So instead of just a general that has extreme breadth, getting an expert LLM that has much more depth in a, let's say, technical area or an understanding of one's products, like an expert. So this is a bit about our company. We were just really founded on this belief that they are the future. This is where data is. Data is in enterprises. I've talked to folks where there's more data for one little use case for an enterprise than there is on the entire internet. So as a result, I think new capabilities are going to arise from the data in enterprises, and those will be different. Those will have this type of expertise as compared to the general models. The general models are not going to, if let's say they never saw German, they're not going to randomly invent German one day. And so it's like letting it see a new type of data. And specifically, this is what our stack looks like. We kind of run it on top of compute. And so we have areas that are focused on pushing model quality, like with hallucinations. So here are different sets of things. I'm not going to go too much into this, but essentially our workloads are optimized for pushing the accuracy up, and then predictable cost and reliability, kind of at this orchestration layer. So to be able to efficiently utilize a huge amount of compute or GPUs and do so reliably. So just getting very high throughput and being able to tune in a way that feels almost free, like basically be able to tune lots of different models so that you can have many of them kind of served at your fingertips and be able to A/B test around them. And security, being able to kind of run on any kind of computer environment. So be able to run on premise, be able to run in different clouds. And interestingly enough, we're also be able to run across different compute vendors. That's been increasingly important for folks to kind of de-risk from just running on NVIDIA. So we make it possible to run on a mix of NVIDIA and AMD GPUs. So this is around security. And finally, on top of all this, none of this matters if you just can't access it. None of this matters. You're like, great, that's basically like similar to the infrastructure that OpenAI has in some ways. But if it's not easy to use, then no one can access it. And so just ease of use for the developer to be able to get this up and running and successfully getting a better model out and successfully pushing the limits of accuracy while doing so quickly and reliably. These are just some interfaces and just a few lines of code. Any questions before I go into more? I would be making the audience interact with me if I were there in person. Just kidding. Okay.
One question from the back, Sharon.
Yeah, please.
Hi, Sharon. My name is Kat from Generative AI. There's a kind of, discrepancy between the knowledge of the world and the client's knowledge. So we are dealing with client data and we are not allowed to we are not allowed to share it very widely. So there's need to map between the word knowledge from Wikipedia and the client knowledge to deliver it faster. So there's the middle elements. There is our subject matter expert. So we need to collect the expertise and then try to map and deliver it quicker. How does Lamini try to help with that?
Yeah, definitely. So maybe just coming back here. Do you have a sample use case that I can go off of that you're thinking that jumps to mind for you?
Let's take just an example where we have the hackathon here. We have a scenario of design or prepare for the third runway of Melbourne Airport, and we have the general knowledge about what the Melbourne Airport, what the airport of the world need previously from the historical data, from the Wikipedia, or from others source of public data, right? So, but we also have like a series of expert in infrastructure in Oracle, and the challenge is how to codify all that knowledge, which are not codes, which are not text. Sometimes it's design template, sometimes it's schematics. Yeah, so that is the different kind of data in different silos, in different knowledge map.
Okay, that's helpful. Did you say airport? I just want to make sure I got that correct. Okay, great. Okay, great. Yeah, so the Melbourne Airport. Yeah. Okay, so it sounds like you're like, okay, there's public data on what I need, but all the private data that you have is stuck in people's heads for the most part, or it's just scattered in different forms. That doesn't seem as conducive to easily transforming into text. Is that correct?
Yeah, that's correct.
Yeah, more or less.
Yeah, so you don't have like, you're not like, oh, this is perfect. We have a beautiful database where we can just connect an LLM to, and hurrah, we have the LLM can actually just have that knowledge. In fact, it feels like a huge pain is just how do we even get the knowledge there in the first place? We know there is expertise, but it's not written, it's not, like you said, codified anywhere. Yeah, so I've seen this a few times, and I think there are two different ways to go about it. One is that I think people are surprised by how much data that's not necessarily in the right format, but can be transformed into the right format by a series of LLMs. So that's one thing. So you can build out an automated pipeline with LLMs to transform, let's say, chart data, CSV data, tabular data into the format that the model can actually consume and learn from and read effectively. So I think that's one piece of that approach. Another piece of that approach is around, we had a customer actually where they had expert fitness trainers and they had some user data, right, of like expert fitness trainers working with different users. But they also said, like all these people have so much knowledge about their fitness area. And so they did actually start just having them write a lot of that down, elicited by a model. So like they were just basically having these experts have conversations with a model to actually collect that in an interview format, and then that can then be ingested back into the model to learn from. So it's basically finding ways to elicit data and also transform that data into the right format. If it is just in someone's head, we can't just hope the model will learn from it. But I think those are two ways of getting started. And then once the model has learned a little bit more, we have an approach that our engineers do called DPO, which is a kind of a more recent form of RLHF. So if you've heard of reinforcement learning with human feedback, which is used to train ChatGPT, basically it's a way to get human feedback back into the model so that these expert humans, they know what is good and bad. They also know what's good and better. So at some point, when building these models, there is a point where, I'm building out a model and I'm building it out for someone else. Let's say it's for your Melbourne airport. And I know the model's getting better up into a point until I have a gap in my expertise, right? And so that's where an expert can actually come in and be able to provide that human feedback back to the model so that it can then learn from that and improve from that. So that's like in the adaptation or tuning process. I don't know. Does that help?
Yeah, thank you.
Yeah. I mean, given what OpenAI just launched, you can also transcribe things. So have them talk to the model and transcribe it if that's easier. But yeah, you do need to get it out of someone in some way. But there are different forms of using it afterwards.
Hi, Sharon Nimish, Legal Director. As you've mentioned, hallucinations can be a blocker, and I think it's generally recognized that AI can hallucinate. But how do you measure the chances of that or improvements in reducing hallucinations over time so you can make informed decisions about how to deploy Gen AI and the applications where you will choose to deploy it?
Yeah, I think it's, the first and foremost thing to do honestly, before people should even be prompt engineering, but obviously people go for it first, is building out an evaluation suite. And building out a evaluation suite that is rigorous, reliable, and scalable, I think are very important factors of the right kind of evaluation. And so evaluation therefore in this case would need to be able to measure whether the model can actually get those key facts and figures correctly or whether those are actually not being done correctly. And so we call this kind of like drawing a boundary or different guardrails for the model. So being able to say, like, find a boundary and give it examples that are correct and incorrect. And then we develop pipelines to make this more scalable. So you can have an army of people, this is what OpenAI does, right? Army of people write out huge evaluation sets for different areas. That's not scalable. It turns out LLMs are pretty good at extending something. So you start off with what we call a seed golden test set, and then be able to expand that using a pipeline of LLMs that you can run that through. So you tell for each example, be able to expand that, say it in a different way, you know, adapt the number that you said was revenue. For example, like hallucinates revenue numbers from financial services companies. That's a deal breaker, right? You can't say the revenue is 10 billion when the revenue is $100 billion. So how do you, in an example where the revenue was in fact 10 billion, or sorry, 100 billion, making sure the model does evaluate and classify to actually extract that right number. And then also in a different scenario, like change that number slightly and have the model actually be able to do that effectively as well. And these models work by evaluating on multiple different examples, like as much diversity as possible as you like change the wording of all these things so that you can properly be confident in whether that boundary was drawn effectively or not. And then once you're able to develop those evaluation suites across the different areas that you do care about, and part of that exercise is discovering what those areas are, then you can become more confident that you can deploy the model for those different areas. And what we're seeing from people is that they're deploying LLMs where they are seeing, above, like, let's say 95% accuracy, but then in other areas they see their evaluations failing, right? Like it's below that amount. It's maybe 50 or 60%. And so they say they have, as you deploy that model, when the prompt coming in is about the example that you have, 90% accuracy, 95% accuracy on, then you allow the model to respond. Otherwise, you kind of that's where you go into like a human in the loop system. So that's kind of that I'm seeing in terms of a production standpoint. I don't know if that's helpful.
No,
There's no Yeah, there's no I know this is probably not what you want to hear as legal counsel, but in AI and machine learning, there's never 100%. The whole thing is about probabilities. But the positive thing is that I think I think companies don't realize how much they are already managing risk and actually comfortable managing risk for different areas, like supply chain, for example. A lot of companies are comfortable managing things that are 70% copy exact or something. So there's uncertainty around what our revenue projections are going to be in every single company, right? So I think there is risk and uncertainty everywhere. This is just a new type of it, and I think people will find more comfortable ways of handling that.
Hi, Sharon. Dennis Marshman here. I've got a question for you. I work in the software development space, and I'm just interested in your view around how LLMs are disrupting sort of the traditional models around software development, particularly when we start looking at internally we have a lot of specialized software which is coming from third parties, and we're using LLM to sort of augment that and maybe access the data that sits behind it. But from a user experience, we often want to embed those models as part of the workflow, as part of the user interface. So do you see that LLMs are starting to disrupt the sort of buy versus build decisions that often companies are sort of grappling with on a day-to-day basis and driving them in a particular direction?
Go into that more. So how LLMs are influencing build versus buy decisions around software they're buying?
Can you say yes?
Yes.
Okay, cool. Yeah, I think, let's see. I know that a lot of people have bought Microsoft Copilot. I think it's an incredibly useful tool. In terms of build versus buy, I mean, people are definitely buying more of these tools to augment existing developers. I think there's clear productivity gains from these tools, the AI tools. Oh, do you mean build as in like build your own LLM for it?
Not so much the LLM, but we're trying to embed LLMs into our workflows. So sometimes we're using software which we're buying off the shelf. Sometimes we're building our own software to develop those workflows. Do you see that the LLM industry or the LLMs in general are disrupting the traditional software development companies and forcing us to move more in-house development or vice versa?
Oh, I see. Okay. The areas where I see people using LLMs most for code are certainly I have a more of a debugging use case, like being able to create some kind of automated loop so that they can augment their developers even further, or even have essentially like a developer intern be able to actually on loop be able to automatically debug something. In terms of the pieces of software, I think LLMs make it easier for people to build more things. I think what I'm seeing is they enable people to write far more lines of code. Now, whether those lines of code are actually useful, I think really depend on what type of code you're writing. If you're writing code that is like for a web app or something that is clearly like very much done online, especially if it's from scratch, not depending on a huge database, code base. I see that being pretty much automated. So I don't see people, maybe this is what you're asking, like using those services as much. But at the same time, I think with more people being able to have access to the ability to write code, I think I see more people kind of using some of those services as well. So whatever is out there online, these models inherently know how to write. So like they inherently know how to write a lot of the open source code out there. And therefore that open source code gets used even more by those who are not necessarily deep experts in it. And that could be a developer who's good at something else. That could also just be, I see like PMs starting to, build at least prototypes out. So I'm starting to see that more. I don't know how helpful that answer actually was. Sorry.
Hi, Sharon. I've got a quick question.
Yeah.
As you know, Oricon's full of engineers and technical experts with deep domain expertise. And we've been talking a lot this week around how can we embed that expertise into our models. And you've touched on a few of those things. I was just wondering, do you have an example from people you've been working with where they've really brought that to life? A technical organization with lots of knowledge and expertise where they've been able to sort of bake that into a model and translate that into value?
Yeah, so I can talk about one that's related to code. So one of our customers is AMD, and they have huge code base for basically designing the next set of chips. And there's no way one of these general LLMs knows anything about that and can help them invent the next one or design the next one. They also just don't have enough engineers to be able to work on this and be able to understand this type of code. So they've essentially tuned an LLM to the first one was to basically start off with something small, like and debug some of the issues around this very specific type of code, be able to connect it to their actual systems that are completely customized. So like things you never would see online and other systems they have internally. And this model is able to basically be an assistive debugger, and they're working on making that a fully automated loop so that bugs can just be caught in a continuous way. Do you want a non-code use case?
Yep.
So I know everyone likes the coding use cases. It's because people get those up the fast. So a non-code use case, we're working with a large German company, and they create, sorry, I can't like actually say the name. They make a lot of adhesives and just very, a very technical area, and they have a lot of manuals on their types of products, right? So, and they have them in different languages, and it's very, very technical, like the chemistry behind it, etc. And so they've ingested that data into the LLMs that they've tuned so that it can actually reason across those and be able to both serve customers and also this is to serve their field techs on it. And specifically how they got that data was they do have a ton of these PDFs manuals on each of their products. It's not geared in a way to like actually tune the LLM, but they're able to build out these data pipelines which are chained LLMs to transform that data into a format that the LLM can learn from.
Very cool. Aaron?
Hi, Sharon. Aaron from Applied Research at Oricon. The example used with Instacart talks about a data set that was universally accessible internally within the organization. A lot of our data that we work with is bespoke and specific to different client jobs, and access isn't necessarily something we want across the organization. So if we're working on sort of a defense project, we don't want everyone to have access to the data, so a universally fine-tuned LLM is not optimal. Do you have an example of where Lamini has been used to actually have tailored and fine-tuned specific examples with an organization you've worked with?
Yes, this comes up a ton. Basically, this is why we've taken the approach of, let's see if I have slide on this. Oh God, it's really probably small on the screen. But essentially, instead of fine-tuning, vanilla fine-tuning means you tune the entire model, right? So then you're like, oh, I have this giant thing that I've put all this data into, and there's clearly, clearly we can't do anything with the access controls here. Great, it's capable, but there's no way we can have that type of data mixing in there. So instead, we built out a way to have hard boundaries around the data so that, let's say you have access to data sets ABC and I have access to data sets CDE. And when I make a request to the model, it's only able to access the data that I have access to. And the way to do that with fine tuning is to tune adapters on the model. So an adapter is like LoRa, for example, and these adapters you can have multiple of them tuned to different data sets, and you can actually layer them as well when you run inference on the model. So that at inference time, you can access data sets ABC or parts of the model that are tuned for ABC, and I can only access the ones that are tuned for CDE. And I specifically chose one where we both can access C because you can composite them like that. And there are hard boundaries in those weights. Like you can literally store them on different servers. So just like data. Yeah, that's helpful. It turns out it's actually also a huge benefit for efficiency of the model. So you can see here in the bottom right corner, you can store, this is saying instead of one server just to run one fine-tuned model, you can essentially run over 4,000 of them on a single server.
Hi, Sharon. Nice to meet you here. My name is Dan. I will be doing my research project with the Gen AI team for the next 5 months. Yeah. Well, it's great to have you here. I feel like Oracle is doing a great job because like the most important thing for new technology to come in is to have people give people the chance to get familiar with the newest technology. So like this is a great opportunity, and then it's great to have you here. My question, I actually have 2 questions. That's for like overall questions. The first one will be related to how which part of the process do you think is the most important piece to increase the accuracy and maintain the credibility of the LLM system to build that as per LLM? And then, yeah, that's my first question.
Okay, great question. I think the most important thing is building out the evaluation appropriately. So I think one of the pitfalls that I see the most is people building out, trying different pieces of technology without knowing whether the model actually improved on their benchmark, because their evaluation or benchmark wasn't actually useful for their business outcome, wasn't actually useful for the things they care about, the hallucinations they actually care about, the hallucinations they expect to get from users. And just taking it down a notch there, I think people don't realize how important evaluation is. So we are very good, like the AI now is very good at optimizing towards an objective, right? It's like super, it's almost too good, but it's really good at that. What is evaluation? Evaluation is defining what that objective is. So whatever you define, it will get really, really good at. So therefore, it becomes like a North Star towards which the AI is able to learn. And so defining that is actually very key to making sure that the model is not hallucinating on the things you care about, is still knowledgeable about general areas of, for example, engineering. And I think it's actually going to be what's most important for, in addition to like the model weights, obviously, because that's a derivative of the data, directly derivative of the data when you tune it. But that's going to be part of what is IP and what is differentiated for every company. So if your competitor has evaluation criteria towards essentially objectives for their LLMs, and those objectives are worse in some way, they can't get a better model no matter what, because they can't assess whether the model is better or worse, right? So like getting that piece right is extremely key towards pointing a North Star for the LLM to learn. So I think getting that piece to be, rigorous and effective is very important, but also to make it scalable is also very important, because how are you going to evaluate it on so many different use cases and also around so many different ways that it could hallucinate?
Yeah.
That's probably number one.
Yeah, thank you. And my second question is like for the general public perspective. So what kind of skills do you think like should people have in this Gen AI array to stay like competitive still out in the market?
I know there's a lot of people saying out there, I don't need my kids to learn how to code, etc. I actually think there's going to be more code writing into the future, because I think software developers are going to turn into the next AI engineer that's going to be able to build and deploy these models in production. That's what we're seeing, that they're able to both bridge the production gap of like understanding what's necessary for an application to push it in production, and also be able to start working on these models now that they've exited the research phase and entered the production phase. So I actually think writing code is more important. Yeah.
Right, thank you.
Sharon, we're at time here. I just want to thank so much for your presentation and taking questions from the group. And thank you for making the time. I'm sure what time it is in San Francisco, but we appreciate it.
It's all good. It's 6:13, so
Oh, that's not too bad.
yeah, it's not bad at all. I would have woken up at 3 a.m. for you guys. You would not have liked it, but yeah, thank you. Thank you for all your time as well, and I hope you have an incredible conference.
Very well. Thank you so much.